So here is our self-study lesson on regression inference. This is the same thing we would cover if we did it all together in class, broken up into a few separate parts. Let's start here. The reading that you would want to do from your text to match up with our discussion comes from those pages, but honestly, the best place to look is going to be AP Classroom, focusing on Unit 9. It's been assigned to you, so you can look at it there if you wish, and there's lots of good questions. All right, here's the basic gist. If you were able to measure every possible XY pair from a population of paired data, every one of them, so you get the entire population taken care of, there would be a regression line that would have a y-intercept of, this is a Greek beta, of beta naught, and a slope of beta 1. However, we hardly ever measure the entire population. Sometimes it's impossible to measure the entire population for a whole host of reasons. So what do we do instead? We take a sample. We estimate the population y-intercept with a sample y-intercept, b naught. And we estimate the population regression slope with a sample regression slope, b1. Just a reminder, don't forget the hats on your y's. We're talking about predicted y's based on a given x. So we've gone through inference now. We've looked at sampling distributions for means, for proportions. We're also looking at some chi-squared stuff. Well, if we know the sampling distribution, we're going to focus just on slopes of these B1s. Well, then we'll be able to construct confidence intervals and run hypothesis tests, which is very exciting. So if we can get that described, which we can, we'll know what to do next. So there's the gist. We're talking about using sample data to estimate a population parameter, in this case referring to the slope.